Hello, I'm Robert, and I'm doing this to help people who are afraid that the things in the sky that the government or the CIA or someone is hiding from us. The CIA know about it, they've been spying and they know something and we don't. This is not possible. It's not at all possible. And I'm going to show you how the astronomers do the searching for asteroids nowadays. It used to be that amateur astronomers did a lot of the finding of asteroids. Now it is just about all automated. And you can watch it going on yourself every night. When it's night time in Hawaii, daytime in the UK, you can just go and watch the telescope online, and here it says observing. In a little while you will see it change and it'll say slewing. That means it's going to take another photograph. These are all the photographs it's been taken so far tonight. And it observes the entire night sky as seen from Hawaii every 3 days or so. There you are. Now it's observing another one, and then it'll slew and then it'll observe. And that is the latest photograph it's taken. So you can just go and look. This is the photograph just taken just a few seconds ago. There we go. And you can zoom in. And that was just taken a few seconds ago in Hawaii, automatically by this telescope. And we may be seeing this before the astronomers. It's immediately posted online. And somewhere amongst all those tiny, tiny little dots, there may be an asteroid. And it's you can understand why the automatic software and the photographing like this all the time is now beating the amateurs. Because you imagine a very keen amateur being able to spot an asteroid just by that, and then you flip it to another one from a little bit later in the night. You see it, one of all those tiny dots. You see it, your eyes are very good at catching motion, and they can see something move from one picture to another. Just that tiny change. But now it's all done automatically with software. Pluto was discovered by an amateur who just looked at lots and lots of photographs and it's called blink comparison. Anyway, so there it is. It's continuing to find more, observing, and then it'll slew, and then it'll observe and slew, and the two of them. That's the other one also doing its thing in Hawaii. And this is what happens to it next. Let's go here, scout page. So these are all the ones. So you've got the automatic software that automatically looks at those photographs. So they go up online, we can see them. They also have software that is checking those photographs. And then it'll produce these things here, which also go online. Temporary designation, because these are not necessarily real things yet. It's basically you can watch the software thinking. And then here's one of the ones it's looked at, and it's sort of thinking, could this be an asteroid? And it's working out if it is an asteroid, that these would be its properties. Not thinking in the human sense, just you can see the algorithm going through its processes of trying to find out if it's an asteroid. And then if it actually decides it is an asteroid, or it probably is one, then it ends up here, which is the NEO confirmation page, and then so that's the scout page, then the NEO confirmation page, and then astronomers now go and look at this, which the software will rule out very obvious kind of mistakes, and then eventually the astronomers go and then they go and get their backyard telescopes, and then they will go out and observe it. And then this is an example. This is an example of the observations. So that is actually the Mount Lenman survey. That's ancient observations from 2009. Let's try and find a recent one. Let's see. all these no hazard asteroids. So anyway, that's the next stage, is that it then appears up here. Let's put the dates on. Dates, and then we'll see dates for harmless objects. Now if we go up there and then look at the ones that were observed in oh no, those are the dates for the futures. How can I easily find the ones that were recently discovered? Oh yes, just the name, silly me. Yes, so if I just go and search the list for 2020, where's my search thing? Here we go. I'll just put in 2020 there, and this will show the list. And first, switch off the first match only, and you can just get a list of all the ones that is found in 2020. And those are all, and see, those are the ones found in the table, and look how many are removed already. So when they first discover an object, then they don't know if it's then they don't know its orbit very well, and so they might there'll be a huge range of possible places it could be, and then they because yes, like an example is that suppose you had just 3 photographs of a golf ball and a 2D picture, and in distance you can see a putting a green, and and you want to know is it a hole in one. Then it would be very difficult to tell from just three images, even if you had say 5 of them, to tell, because you've got to get the depth apart from anything else, and you've got to work out the exact parabola that's going through those points. It'd be very hard to tell. It's going to be a hole in one if you just got say 4 or 5, even half a dozen photo frames, and you don't actually see where it ends up. So that's what it's like with these. They just got a few observations, and it's very hard to tell if it's going to come anywhere near Earth. And then after they do more observations, they work it out more accurately, and they remove them. And all these ones have been removed so far this year. Those were discovered this year. They were in the table for a while, and then they were removed. Let's look at one that hasn't been removed. So it's a tiny one, 18 meters. So that's not going to pay. It's smaller than the Chelyabinsk one. You can go and look at the observations. So let's bring up the observations, and you can see. So this will be a better idea of what's going on. So there's Pan-STARRS found it, apparently. So some are found by ATLAS, some found by Pan-STARRS, some by others. And then you've got all these. So the Carl Schwarzschild Observatory, the Mount Observatory, the Stewart Observatory, and some of these are actually amateur observatories. Someone with a telescope in the backyards. It depends on the magnitude. Magnitude faint 21, 22. That's quite faint. But anyway, I'm not an observer. I don't know. Let's try and find a bigger one, and then we'll get more. Where have we gone? Back to 2020. And we'll get more observations. Let's see. Just randomly choose another one. 212 meters in time. That's a little bit bigger. So that'll have a lot more observations probably. No, not so many. It must be very recently discovered. Third. No, it just wasn't close up for very long. I'll try one more random one, then I'll give up on that. But I wanted to give you an idea of, anyway, if you get one that's got lots of observations, then you start getting lots and lots of just various observatories observe. Anyway, you get an idea that you've got all these observatories that observe them, and you can actually look up what this observatory is, and that was magnitude 20, which is a little bit brighter. Višnjan Observatory. and we can actually find this observatory. So, yes, here we are. So this is an amateur observatory. So I found so that's an amateur. It's headed by, I think, anyway, it's a public observatory. They found 108 minor planets and 1,294 accredited to this chap Corrado Kolovic. And so there's his observatory, or their observatory, public observatory. And here's some of the minor planets they discovered, very prolific. Let's find out about this chap who has discovered so many asteroids. He's a Croatian teacher. So here we are. Here is one of these. So he is a Croatian teacher. He's an amateur, and he has found 1,162 minor planets up to 2001. Since then, it's and 132 of another ones. Now notice how it's only up to 2001, because after 2001, it just started getting so difficult for amateurs to spot them, because these big telescopes are finding them so quickly with their automated surveys. But if the ATLAS would stop working, and Pan-STARRS and all of them, they're not all going to stop working, but if they did, then the amateurs would pick up these asteroids, quite a lot of them. But they can't compete with, these find hundreds of them, thousands of them a year, I can't remember how many they discover a year, but vast numbers. So they're no longer discovering them, but he is observing them, and he's following the telescope. So there we are with his telescope, but here you are, quite an unusual design. Look at it, very high up on a pillar. How interesting. He's built up in a high kind of pillar, presumably to avoid I've never seen any of you amateurs watching this, have you ever seen something like that built up quite high on a kind of pillar like that? Presumably to avoid the obstructions of nearby houses and things. Very interesting. Anyway, so here's quite a nice example of someone who is out there probably every clear night, and the people out there observing it from this amateur observatory. And so I'll put links to all this in the video description. I just discovered that just now, as I was talking to you. But so there are lots of amateurs out there observing. These find the asteroids, but they take so many images so quickly, huge images. Each of these images spans 14 times the diameter of the moon. Absolutely huge images. And it's looped to another one and another one, observing all night. And in 3 days, it can observe the entire night sky. And you have 2 of these in Hawaii. So that's about that. And then I just want to talk a little bit about I did another. I think I will just stop this video and then do another one if the bits I've left out, because I did a previous one and I get confused about what I've said and I don't want to repeat myself. So basically I've explained how I'll do a separate video about how ATLAS works, more details that I haven't explained in this. I think I just explained the sequence here. So how it happens, just a quick summary of how it works. So you have the telescopes. I've got an image of the telescope here somewhere. Let's see if I can find one. There we are. So that's the ATLAS telescope. It's 0.5 meter across. It's not huge. It's quite large for an amateur one, but it's not huge. It's quite small by professional standards. So it's 0.5 meter across, and that's what's actually taking the photographs. 2 of those. Then the photographs appear online, similar to that. You could go and watch them appear online. Then from there you go to the Scout page, if I can find that. Is that the Scout page? Yeah, they go to the Scout page. And then you get the software thinking about it, which you can watch online. And then it goes to the NEO search page, NEO list, oh yes, then it goes to the annual observation page, which that chap could already be observing. And then it goes to this page, and then you have these people observing it, and then they work out, and then the observations pop up here. So as soon as whenever that one was, which one was it? Try and find the one with his observations on it. Was it? There we are, that one. And so there he was out on the 3rd of, he was out on the 3rd of April observing this one. And he must have eventually gone out of range, because they've only a few observations on the 2nd, the 3rd and the 4th of April, and so he was very quick off the mark. He was observing it, not the 2nd, he was observing it the day after it was discovered. And then it's observed, and it's here, and then you can go and watch, and you get the overview. So there's nowhere anywhere in all that where anything can be hidden. And then you have, it then goes on the JPL page, and it'll go on the minor planet page, and then they'll work out an orbit for it very quickly. You can go and look up that orbit, and then as the time goes on, they refine it more and more, and so that's how it works. And the orbit then gets more refined, and then if there's any risk of it coming anywhere near Earth, then it starts getting a warning level in this page automatically. And so at the moment there are none. And then if you look at the warning levels, I've got a list of them here somewhere. Then it's nearly always no hazard. From time to time you will get normal, that's green. And so don't worry if you see a green one on this page from time to time. They say it's a routine discovery, and it usually gets reassigned. In fact, just about always gets reassigned to 0 within a few days or a week or so. And then you may get a yellow one, and that means that the astronomers are getting interested. And they think it's important to look at it closely, especially if it gets to 3 or 4, then they're meriting 2, 3 or 4, it merits attention by astronomers. That's the highest that Apophis got up to 4, and then it went down again. And if you look at that example of a golf ball, and you've got your 3, 4, 5, 6 observations, then it's like, when you've got to say 10 observations, you might say, it looks as if it's going really close to the hole. It could be a hole in one, but you don't know for sure. And then 7, 8, 9, 10, and then you say, it's going to be within, say, half a metre of the hole. And then a few more, you say, it's going to be within 30 centimetres of the hole. Now it's pretty obvious that it's going to be within 30 centimetres of a hole. Doesn't mean it's going to be a hole in one. So people get confused by this, that sometimes the numbers are going up and up, and they're going 2, 3. So with Apophis it went all the way up to 4. That didn't mean that it was going to hit, because they just discovered, as they narrowed it down, they found it was going to go quite close but miss. So if it's going to go quite close and miss, then you can expect it to go up and up and up until they get its orbit refined enough to discover that it's going to miss. Just like with a hole in one, that's not a hole in one. You're actually going to miss by, say, half a metre. But as if you're going to miss by half a metre, say, you're quite a good golfer, but you're not at the point of doing a birdie, whatever they call it, then as you do the observations one by one, then you would start saying it could be a hole in one. It's not way out. It's within 10 metres. It's within a metre. It's well within a metre. Could it be a hole in one? But then he's actually missing by half a metre, and so then it'll start going down after that. It'll say, no, it's not a hole in one, he's going to miss. And so that is exactly how it works with these things. So sometimes it go all the way up to 4, that's only happened once. But it wasn't a hole in one, it isn't going to hit Earth, so they missed. It's only when you get to 5, 6 and 7, and even then, if it went all the way up to 7 threatening, that is like the half metre thing, really. It's like, it still doesn't mean it's going to hit. It's only when it gets to, so it could go all the way up to 7 and then go all the way back down to 0. Indeed, if you got to 7, still the most likely thing would be that it goes back down to 0. And it's only when you get 8, 9 or 10 that it's going to hit. And then, so if you get to 8, 9 or 10, then you know it's going to hit, then that doesn't mean anything horrible is going to happen. If you've been tracking it, it's gone all the way up to 8, and you know it's going to hit, then that means you would then be knowing where it's coming from, and you know its orbit. You get radar observations as it gets closer, and within a week of the impact, you would know nowadays with the modern observations, modern calculations, the modern very accurate radar measurements and everything, then a week or two in advance, you will know within a kilometre and down to maybe 100 metres or so where it's going to hit on Earth. Unless it's a very glancing blow, if it's a reasonably not very glancing one, you will have a very, very accurate idea. And then you can say, oh, it's going to, so when they do the FEMA asteroid preparation exercises, then you can guarantee that it's going to hit a US city, not because asteroids are at any danger of hitting this. It's very, very, very unlikely that it would hit a US city because there are just not many US cities compared with the area of the entire world. The area of all the US cities combined together, only a tiny fraction of the entire world. Extremely unlikely that we have an impact on a US city in the next century. Very, very unlikely. Indeed, it's probably going to be thousands of years before the next impact on any city, because the cities occupy only 1% of the Earth's surface, and you get one of these every century or so. So multiply century by 100, you have 10,000 years. So it's probably going to be several thousand years before the next impact on a city of even the small ones, of 40 meters or something. So, but just in that extraordinary chance, suppose it was going to be an impact on a city, and they always have this, they always do it, it's going to be impact on a US city because they want to test it all the way through, you see. So they always make it end up on hitting on a city because they want to make sure they're prepared and ready to deal with the city impact, even though it's extraordinarily unlikely. Most likely, if it did land in the US, probably in the middle of the Arizona desert or something. So very unlikely that it's in a rural area, because most of the US is rural, it's countryside. So extremely unlikely it actually does land in a city, even if it lands in the United States, and very unlikely it lands in the United States because it's only a small part of the entire world. And most likely that the next asteroid impact lands in the middle of the ocean, because 4/5 of the world is ocean. So that means 4/5 of them, 80 out of the next 100, are going to land in the ocean. So that's the way it works. Your risk is extremely tiny. And so, but anyway, just suppose, extraordinary situation, that this asteroid, they discovered they've been monitoring it, went all the way up to red, and they, because it's in the table, they are monitoring it, then they would know a week in advance, they would know that it's going to hit in Central Green, Central Park in New York, say. So that'd be quite a likely thing for the exercise, though extraordinarily and possibly unlikely in real life. But just suppose that did happen, then they know in a week in advance, and they say, oh, well, you've got to, or everybody who's got anything valuable in New York, you need to watch out. It's going to be a 50-meter asteroid. It's going to create a crater this size. If you're in that crater zone, make sure not to be on Central Park and nearby buildings, evacuate anything valuable, and all the people, make sure you're nowhere near this at the time. It would probably blow out windows to most of New York, so you would tell people from New York to evacuate. If it's a big one, it would even the countryside around New York would have to be evacuated, and if it was a somewhat big one, that's very unlikely. And you talk about lots of buildings in New York being demolished, but still nobody would die, because they would have left New York, and only a stupid person would be still in New York on the day of the impact when they've had a week of warning. You'd have to be exceptionally stupid to think that you can survive an asteroid impact. And So the government would be saying, you've got to get out, get out, get out. That's what they do with hurricanes. With hurricanes, you sometimes see people do hurricane parties. They just wait for the hurricane. But I don't think, hopefully you wouldn't get an asteroid party when people sit in the middle of the impact zone having a party. That would be very silly. But anyway, so the governments are always there, are always the ones who are telling people, get out, go away. This is not safe. And so only if you don't listen to that warning, and you're very, very stupid, and you try and get a selfie next to an exploding asteroid or something, those are the only people who would be at risk. So that's, hopefully this has helped some of you to understand. It's not something to be scared of. All these asteroids they're discovering make us much, much safer. They can spot. I will do the ATLAS thing. So yes, I don't think I did do it. So I'll do the ATLAS thing. I will explain that. And then it's just one video. It's less than half an hour. It's 26 minutes. Right. So just the ATLAS. Then these are this is where it is. It's in Hawaii. 2 big telescopes, 100 miles apart, about 150 kilometers apart, and it automatically does its observations automatically and promptly submits them to the Minor Planet Center just automatically over the internet, and it just explains how it all works, and it also looks for other kinds of things as well, and this is how many it's discovered so far. It's discovered 479 near-Earth asteroids, 50 potentially asteroids. It doesn't mean that they can hit and 50 comets, and all these supernovas, very distant supernovas, nothing to worry about. And these are the technical details. You have you can even spot a 1 meter asteroid. It's just a fireball, and you can spot that 5 hours in advance. There have been some examples of it doing that. So there were several I think there have been 3 or 4 fireballs that have been predicted in advance. And so most fireballs, there are lots of fireballs in the atmosphere every year, and most of them, but nowadays, then some of them get seen. That's very small, but it still does spot some of them in advance, and then you can tell astronomers. So I think I've got if you get one of these apps to look at the sky, and go forward to say 2050s, your app will be saying, there's going to be a fireball in 10 minutes, go and look in that direction, you'll see your fireball, because they'll all be tracked by then, even small 1 meter things. But that's not happening yet for the small ones, but for the big ones. So, oh yes, it does survey coverage, 20,000 square degrees 3 times every night. So it does each one 3 times in order to find it, in order to get 3 observations, which is enough for a preliminary orbit. And it'll spot 100 meter diameter one 3 weeks in advance, and that'll be a lot more than it spots 60% at 50 meters, and the bigger they are, the more of them it spots in advance. 10 meters with 2 days warning, a week with 50 meters, a month with 140 meters. So 20 meters is the size at which is the Chelyabinsk skies. 50 meters is the 1908 Tunguska impact kind of a size. 140 meters is very rare, and it's 1 kilometer before it starts to be big enough to slightly dim the atmosphere worldwide for a few weeks and have an impact on crops. None of these are below 1 kilometer. It doesn't have a global effect. And anyway, so that when it gets to 1 kilometer, then just about anything at 1 kilometer is going to be spotted in advance. It's very, very hard for 1 kilometer asteroid to hide. And we know 95% of those, 98% I think now, in advance. We know 98% of them, and none of them can hit one a very remote chance in 2880 expected to miss. As we find out more, we'll probably prove it misses. 1950, that's 4 centuries from now. Out of over 900 has been discovered. and there are only a couple of dozen or so left to find. So very unlikely that anything of 1 kilometre size can harm us. And if there is, it's most likely to be, you only get one of those hit every few 100,000 years, so it's most likely going to be thousands of years if there is one that's going to hit, that we find, and certainly centuries. Very, very unlikely that we have one that big that can hit us in less than a few decades. And we could deflect it if it's got a few decades of warning, and if it was even just a couple of years of warning, then you have to evacuate the impact zone. But that's extraordinarily unlikely. And so it's the small ones they're focused on now. And your personal risk is absolutely minute. It's worth doing because there's 7.5 billion people in the world. And so even a 1 in a million risk, which is absolutely minute personally, could be 1,000 people. So obviously you want to look out for something that could possibly harm 1,000 people, even though that's extraordinarily rare. It's usually, there have been a few cases where more than one person, or even more than 3 people have been killed. There's a case of 14 people were killed by an asteroid. But in that 20th century, and in Mexico, and really your main risk is not from asteroids. It's if you're worried about something falling out of the sky, worry about hailstones. And there's a very sad, unfortunate occurrence in the United States. Last time someone died of a hailstone was in the year 2000 in the United States. Worldwide it happens fairly often, but because the world is very big. But last time in the United States was the year 2000. And this was someone, rather sad situation. He got a new car, a new van I think it was, and he really cared about it. He saw it being damaged by the hailstones, so very foolishly he went out to the car and drove it somewhere safe. He managed to get out to it, drove it, and then he was killed on the way back. If your car is being damaged by hailstones, it's not safe to go out and try and rescue it, because that means you can be damaged by hailstones. So anyway, he was killed by hailstone. It's very rare. It used to be more common in the United States when you had lots of people working in the fields. But nowadays you have the farmers and their tractors, and if you're in a tractor, you're not going to be killed by a hailstone. And but they used to have lots of people out in the farm. So people are out all day and all night and do work all weathers, even when it's very bad weather. Then those are people who can die of hailstones. Anyway, so that's that's about your risk of an asteroid impact is extraordinarily very, very, very tiny. Much less than dying of a hailstone, which in turn is much less than dying of lightning, which happens to 20 people in the United States every year. Nobody has died of an asteroid in the United States ever in recorded history. Probably maybe way back in indigenous people, maybe someone way back then did at some point. There's no record of it ever happening. And so hopefully this helps you to be less scared of asteroids. It's not something to be personally scared of, and it's a great thing that they have these people observing in the skies. And it's just like hurricanes. So we have nowadays, there used to be lots of people died of hurricanes. Now it's greatly reduced because you have the hurricane warnings. It used to be that a few people per century died of an asteroid. It can still happen, but 60% of those people will have their lives saved now. So instead of maybe 10, it'll be 4. And then it'll go down till the none going to die. And so that's basically where it's at. And then very occasionally, maybe every few centuries, more likely thousands of years, you get a slightly larger one, which unfortunately, and if actually hitting in an urban area and hitting a city, you're talking about thousands of years most likely, then that may happen occasionally. So but it's worth taking the precautions to be ready for that. it probably won't be needed for 1,000 years, but we're ready just in case for even the somewhat bigger ones. So I hope you're a bit less scared of asteroids now as a result of watching this video. That's my aim. And if you're scared of any of this stuff, do join the Doomsday Debunk group. So I mean, that's my aim because that is the situation. I just tell things as they are. And the situation is there's nothing to be scared of, but personal risk is way, way, way down, way below even hailstones. And so I hope that this is conveyed to you accurately and that you understand now that it is not a significant risk. It's not something to be scared of at all. We just shouldn't be scared of asteroids. So, hope this helps.